Good day, viewers. We continue with the questions that we had not finished in the previous video. Remember, in the previous video, we went as far as question 11 and we were able to answer this question. Now, in this video, we will continue from question 12 all the way to question 20 of this 2024 GCE Science Paper 2 past paper. So let's get started. But maybe before we get started, I suggest that you subscribe to my YouTube channel, share this video, like this video, leave a comment in the comment section so that would be able to give me feedback on how this is going so far. So we continue with question 12. Question 12 reads, how does a catalyst increase the rate of a chemical reaction? How does a catalyst increase the rate of a chemical reaction? So a catalyst, as we may be aware, or as you may be aware, a catalyst is basically a substance which speeds up a chemical reaction and it does not get changed during a chemical reaction. So this speeding up of a chemical reaction, a catalyst basically does that by lowering the activation energy. And so how does it increase the rate of a chemical reaction? It does this by, if there is an answer which says low or reducing the activation energy, that is the answer. So when we go to option A, says by increasing the activation energy, no. By lowering the activation energy, yes. The catalyst increases the rate of a chemical reaction by lowering or reducing activation energy. What about C? Lowering the kinetic energy of the particles, no. Reducing frequency, no. So the answer for question 12 is B. So question 12, the answer is B. What about question 13? Question 13 reads, identify the correct electronic configuration of an element used to treat water. So the question is, what is the element used to treat water? The element used to treat water is chlorine. Now, chlorine, when we go to the periodic table, we will learn that chlorine has the following mass number and proton number. So chlorine is found in group 7 of the periodic table. So this is chlorine. We have proton number of 17, mass number of 35.5. So this is our chlorine. We have 35.5 and we have 17. In another video, I'll be able to explain why chlorine has 35.5 as its nuclear number. So now, if chlorine has 17 as the proton number, and in its neutral state, it also has 17 electrons, because these are protons, and in its neutral state has 17 electrons. So if we are to write the electronic configuration of chlorine, we would have 2, 8, because 2 plus 8, that's 10, we're remaining 7. So this would be the electronic configuration for chlorine as an element or as a substance used to treat water. So when we go back to the question, we will look for the one which has this. So the answer should be what? C. The answer for question 13 is C. Let's go to question 14. Excuse me. The following diagrams show different experimental setups used to investigate the conditions necessary for corrosion of iron metal to occur. Okay, so iron metal basically corrodes under the following conditions. Iron corrodes when there is atmospheric oxygen, and also when there is water or moisture. These are the conditions necessary for the corrosion of a metal or iron metal, to be specific. But you can also increase the rate of corrosion if you add salt water. Salt water. Why? Because salt water contains it contains ions which will facilitate, because what you need to understand, which will facilitate the corrosion, because what you need to understand is that corrosion is basically making a metal turn into its compound state, because in its pure form it is unstable. So corroding basically makes it react with a substance. In this case, we're talking about iron. Iron will react with oxygen to form iron oxide. So whenever there is salt water facilitates that because of the ions which are present in it, and that will increase the rate of corrosion. So the answer for this question is C. Because when we check here we have a layer of oil, oxygen may not penetrate. Boiling tube, we have iron, nail, water. Yes, this would be our option, okay, because we have oxygen, the presence of oxygen and water, that would take place, but we look for others. This one, dry cotton, this will not be, the cotton may not facilitate the increased corrosion rate. What about salt water? So this would be the best option in this question. So the answer for question 14 is C. Question 14, the answer is C. What about question 15? Question 15 reads, in which of the following pairs of reactant will a displacement reaction take place? In which of the following pairs of reactant will a displacement reaction take place? So we have the following. Reactants is aluminium nitrate plus magnesium. Aluminium nitrate plus magnesium metal. Another one is copper 2 sulfate plus silver. Copper 2 sulfate plus silver metal. Copper 2 sulfate is in aqueous, even aluminium nitrate is in aqueous because all nitrates are in aqueous state. Then the other one is magnesium sulfate and copper. Magnesium sulfate plus copper. And the last one is zinc sulfate plus iron. Zinc sulfate plus iron. In the previous video, I was able to explain how you can be able to tell the state symbols that should be ascribed to sulfates. So there are only 3 sulfates that have a state symbol of solid. That's barium sulfate, calcium sulfate, and lead sulfate. The rest of the sulfates, they have a state symbol of aqueous because they are soluble in water. Now, which one of these, when they react, displacement will take place? So here, what you need to understand is that displacement reaction will take place if the metal which is reacting with a compound is more reactive than the metallic ion in the compound. I hope you understand that. If iron is more reactive than zinc, then displacement reaction will take place. But that again takes us back to the reactivity series of metals. We need to know the reactivity series of metals. How is the reactivity series of metals? So, the most reactive metal, as things stand in our syllabus, is potassium. So, you have potassium, you have sodium, you have calcium, you have magnesium, you have aluminium, you have zinc, you have iron, you have I think you have lead, you have copper, you have silver somewhere there, and then you have gold. Now this is how I remember the reactivity series. Potassium is please, sodium choline, no, sodium is stop, calcium is choline, I saw this somewhere, magnesium is me, aluminium is A, zinc is zebra, iron is I, lead is like, C is cute, let's go to God, is girls. So this is strictly meant for learners. Learners basically like such mnemonics or things to make you remember. This is not something you can easily forget. Please stop calling me a zebra. I like cute girls. Okay? So you would be able to tell that between copper and silver, between cute and the girls, there is some ornament which is silvery. So there is silver in between. So when you do that, you'll be able to remember the reactivity series. So what it means therefore is that if you have sodium sulfate and you react it with potassium, the reaction is able to proceed. Why? Because potassium can replace sodium. Why? Because on the reactivity series, potassium is more reactive than sodium. So it is possible to have this reaction, but it is impossible to have such a reaction, potassium sulfate reacting with sodium, because sodium is less reactive than potassium. It is impossible for sodium to displace sodium here. That is the whole idea. So when we come back to this, we will use the reactivity series to determine where the displacement reaction can possibly occur. So here, which one is more reactive between zinc and iron? So when we follow this, we find that zinc is somewhere here, iron is below zinc. So iron cannot replace zinc. It's not possible. What about here, magnesium and copper? Which one is more reactive? When we come here, copper is even less reactive. Okay? And when you react copper with an acid, copper is even unlikely to react with an acid. But when you look at magnesium, it is way up here. So this reaction is not possible. It cannot take place. What about copper and silver? Silver is below copper, so it cannot displace copper in the copper sulfate compound. So it is not possible. We're remaining with one option, which I think is the answer. Magnesium and aluminium. Aluminium is below magnesium, so magnesium can displace aluminium. So magnesium can displace aluminium here because magnesium is more reactive than aluminium. So this reaction can rightly take place, plus aluminium metal there, aqueous, and then you'll have to finally balance the equation. But that's not our point. What we're looking for is the one where displacement can take place. So the answer is this one. The option A is the answer for question 15. Question 15, the answer is A. We move on to question 16. Question 16 reads, the diagram shows the collection of a gas T during its production. So now there is this method of collecting this gas. Okay, you have the delivery tube here, and you have a gas jar here. So what you need to understand is that whenever you have this collection method, This method is called upward delivery. Okay, this is called upward delivery or downward displacement of air, because the air is being displaced downwards as this air gas is coming. And the reason is simple, because this gas which is being collected in this method is less dense than air. So as it comes out, it will basically rise to the top, but it will be prevented to proceed upwards by the gas. So it begins to collect up on top here, and then the gas begins to do what? To go down or come out, and it is being displaced downward. So this is downward displacement of air. At the same time, the delivery tube is facing upward, so this is upward delivery. So the method is called upward delivery or downward displacement of air. And the reason is because the gas that is being collected is basically less dense than air. So that's the thing about this. So when we go to the question, what interpretation can be drawn from the method of collection of the gas? It has a density equal to that of air? No. It is denser than air? No. It is less dense than air? Yes. So the answer for question 16 is C. Question 16, the answer is C. We move on to question 17. Question 17 reads, why is hydrogen referred to as a clean fuel? Why is hydrogen referred to as a clean fuel? Well, hydrogen is referred to as a clean fuel because it does not pollute the environment. That is the basic reason. As it burns, it is a less pollutant, so to speak. So it doesn't pollute the environment. Option A says it burns in oxygen to give more energy, and even other fuels, they do that. So the best answer would be because it does not pollute the environment as it burns. Okay. The answer for question 17 is B. What about question 18? So that we go to 19 and finally 20. So question 18 reads, the chemical compound which can best be used to make hand sanitizer is. So first of all, what you use to make hand sanitizer is ethanol or alcohol. Okay, it's an alcohol. So ethanol is the best, and its formula, the formula for ethanol is C2H5OH. But sometimes they will bring the condensed formula of ethanol, where we are going to have CH3CH2OH. Okay, why is this formula also possible to come? Because it is the condensed formula. Condensed formula, meaning that when you go to its structural formula, you have COH, and then you have the hydrogen like that. Okay, and then you have H. So the condensed formula basically means that you are going to write this carbon with the 3 hydrogen atoms bonded to it. Again, you write this carbon with the 2 hydrogen atoms plus the hydroxyl functional group there, like this. So if you find these 2, okay, this one and this one, it's one and the same. Please don't get confused. Just count the number of carbon atoms. That's the whole idea. From the general formula, CnH2n plus 1OH, you just have to count the number of carbon atoms. So we have 1, 2, hydrogen 1, 2, 3, 4, 5, plus this one 6, and then O. We count this one as 1 because it is a functional group. Then when you come here, it is the same as this 1, 2, this 5, and then OH. So now, ethanol or an alcohol is the one that is used to make the hand sanitizer. So here, the chemical compound which can best be used to make hand sanitizer is, so we're going to look for that one. This one, C2H3, no, don't know what this is. No, This is a carboxylic acid, and this one is the answer for question 18. The answer is D. Question 19. Question 19 says, large petroleum molecules undergo cracking to produce small molecules which are more useful. What would be product X when the hydrocarbon, this one, C20H42, is cracked according to the following reaction? So we have this reaction here, this gamma reaction here, which we have been shown, which is C20H42 cracked to 2X plus C4 H10. So it should be H10 right there. So this is H. It was just a mistake I made. This is H10. So now, the whole idea here, let me just go straight to the point. You need to understand that this is more like decomposition, and the same number of atoms must be produced on the other side. Okay? Yeah. So the same number of atoms this side must be reflected this side. Now here there is a 2. So there should be this product. Remember here there is C4.